Hello and welcome to AWS Fundamentals Training. This video aims to give you a clear, high-level understanding of AWS services, core concepts, and how cloud computing helps you build and scale applications efficiently. Here's a quick overview of the topics we'll cover in this training. We'll start with an introduction to AWS and cloud computing, including its advantages, types, and service models, as well as AWS support plans. Then we'll move into an overview of key AWS services such as IAM, S3, Glue, Redshift, Athena, Secrets Manager, and Parameter Store. First, we will talk about cloud computing. In March 14, 2006, AWS launched their very first service, S3. As of writing, there are 38 regions, 120 availability zones, 700+ CloudFront POPs, 13 regional edge caches, 43 local zones, and 31 wavelength zones. So what are the advantages of cloud computing? Cloud computing has 6 key advantages. First, you trade fixed expenses for variable expenses, paying only for what you use. Second, you benefit from massive economies of scale, which lowers overall costs. Third, you stop guessing capacity, easily scaling resources up or down as needed. Fourth, it increases speed and agility, letting you access resources in minutes. Fifth, you stop spending money running data centers, so you can focus on innovation. And finally, you can go global in minutes, deploying applications worldwide with low latency. There are 3 types of cloud computing services. Infrastructure as a Service, or IaaS, provides virtual servers, storage, and networking where you manage the OS and applications. Platform as a Service, or PaaS, gives you a ready-to-use platform to build and deploy applications without managing infrastructure. Software as a Service, or SaaS, delivers fully managed applications that you simply use over the internet. AWS uses a shared responsibility model. Highlighted in gray are managed by the user, and highlighted in orange are managed by AWS. Now we move on to the models of cloud computing. There are 3 types. First is on-premise. This is the traditional setup where all systems and data are hosted within your own company's data center. You have full control, but it requires higher upfront costs and ongoing maintenance. Next is cloud-based. Here, the infrastructure is hosted by a cloud provider like AWS. There's no need to manage physical hardware. You can scale resources on demand, and you only pay for what you use. Lastly, we have the hybrid model. This combines both on-premise and cloud. Critical or sensitive workloads stay on-premise, while other applications run in the cloud, giving you flexibility and a smooth path to cloud adoption. Moving on to their support plans. AWS offers 5 support plans to suit different business needs. Basic, free plan with 24/7 access to customer service, documentation, and forums. Developer, for experimenting and testing, includes business hours email support and guidance for best practices. Business, 24/7 support via email, chat, and phone, with access to AWS Trusted Advisor checks and faster response times. Enterprise, on-ramp, for growing organizations needing enterprise-level support guidance at a lower cost, with 24/7 access and a technical account manager for critical issues. Enterprise, full enterprise support with a dedicated technical account manager, proactive guidance, and fastest response times for mission-critical workloads. Moving on to AWS Shared Responsibility Model. This defines how security and compliance duties are split between AWS and the customer. AWS is responsible for security of the cloud. This means protecting the infrastructure, hardware, software, networking, and facilities that run AWS services. Customers are responsible for security in the cloud. This includes securing their data, applications, operating systems, and managing user access. AWS has a comprehensive compliance program to help organizations meet regulatory, security, and industry standards. Now we go to their services, starting with Identity Management Access, or simply IAM. IAM is a service that helps you securely control access to AWS resources. With IAM, you can create users, groups, and roles, and assign permissions to control who can access what. Also, it supports fine-grained access, ensuring users only have the permissions they need. IAM also enables multi-factor authentication (MFA) for extra security and integrates with your existing identity systems. In short, IAM ensures that the right people have the right access to your cloud resources, helping keep your environment secure and well managed. In AWS, there are several ways users can access your environment. First-time access users, new users accessing AWS for the first time, typically given initial credentials and guided to set up MFA and passwords. IAM users, identities created directly in IAM with permanent credentials to access AWS resources. Permissions are assigned via policies. Users in IAM Identity Center, formerly AWS SO, centralized users managed for single sign-on, allowing access to multiple AWS accounts and applications without managing individual credentials. Federated existing users, users from your existing identity systems like Active Directory or Okta who access AWS through federation without creating separate IAM users. This simplifies access management and improves security. The key components for managing access are IAM groups, collections of users that share the same permissions, making it easier to manage access for multiple users at once. IAM users, individual identities that belong to groups or stand alone, with credentials like passwords or access keys to access AWS resources. IAM roles, temporary identities that can be assumed by users, applications, or services to access resources without permanent credentials. Commonly used for EC2 instances or cross-account access. IAM policies, documents that define permissions for users, groups, or roles. Policies specify what actions are allowed or denied on which resources. IAM is global, works across all AWS policies, use JSON, defines permissions in a structured way. Access methods through console, CLI, or SDK. Root account is email-based and has full admin access. Security, activate MFA and apply password policies. Users and groups, users inherit permissions from groups for easier management. Best practice, create individual IAM users, use MFA and assign to groups. Next is Simple Storage Service, or simply S3. AWS S3 is one of the longest-serving AWS services since 2006. Think of it as a super flexible cloud folder system where you can store anything from tiny files to 5 terabyte objects, and it scales automatically as your storage needs grow. Every file lives in a bucket with a unique global name, and buckets are private by default unless you decide to share them. Behind the scenes, S3 tracks your files with keys, stores metadata, and even keeps versions if you want. It's secure, durable, and reliable, perfect for backups, archives, and web applications. S3 offers flexible storage classes from high-performance frequent access to ultra-low-cost archival, helping businesses balance cost and availability based on data usage. S3 Standard, for frequently accessed data, low latency, high durability. S3 Intelligent Tiering automatically moves data between frequent and infrequent tiers to save costs. S3 Standard IA Infrequent Access, cheaper than standard for data accessed less often, with retrieval cost. S3 One Zone IA, lower cost infrequent access, but stored in a single AZ, less resilient. S3 Glacier, for archival, low cost, retrieval in minutes to hours. S3 Glacier Deep Archive, cheapest, long-term storage, retrieval in hours. Here are the key features of S3. Tiered storage availability. Choose storage classes, Standard, Iowa, Glacier to balance cost and access needs. Lifecycle management. Automatically transition or delete objects based on rules to optimize costs. Versioning. Keep multiple versions of objects to prevent accidental deletion or overwrites. Encryption. Protect data at rest and in transit using AWS-managed or customer-managed keys. Access control ACLs and bucket policies. Fine-grained control over who can read or write data. Some tips in S3 includes unique bucket names, Each S3 bucket name is globally unique. You can't use a name someone else already has. Global and regional view. You can view all your buckets globally or filter by individual regions. Cross-region replication. Replicate data to another region for backup or disaster recovery. Flexible storage and encryption. Change storage classes or enable encryption anytime, even on existing objects. Restricting access. Bucket policies control the whole bucket. Object policies control individual files. IAM policies control access for users and groups. You can also use bucket policies to make data public if needed. Static website hosting. S3 can host HTML websites, but not databases. Automatic scaling. Storage scales automatically based on your demand. When accessing S3, here you can see the bucket list. Upon accessing a bucket, you can see all the objects and folders under that bucket. You can also opt to enable bucket versioning. It is helpful to keep multiple versions of objects to protect against accidental deletion or overwrites. Moving on to the next service, AWS Glue. AWS Glue is a fully managed ETL service that makes it easy to prepare and load data for analytics by automating most of the traditional ETL tasks. Features of AWS Glue includes Data Catalog, automatically discovers and organizes your data for easy search and query. ETL Jobs, lets you create and schedule data transformations. Serverless execution, runs ETL jobs without managing any infrastructure. PySpark integration, supports custom Python Spark scripts for powerful data transformations. AWS Jobs automate extracting, transforming, and loading data from different sources, making data processing faster and easier without manual effort. When accessing AWS Glue, you will be redirected. A few things you can do here includes visual ETL design, build ETL workflows using an easy drag and drop interface, job creation and editing, create, edit, and manage ETL jobs without coding or with PySpark scripts. Run and monitor jobs, execute ETL jobs, and track their progress and performance. Data preview and debugging, preview data at each step and troubleshoot issues easily. Integration with Data Catalog, automatically access and use your catalog datasets. Upon clicking Visual ETL on creating a job, you will be redirected to the Visual Studio where it lets you drag, drop, configure, run, and monitor ETL jobs all in one screen. Features of a data catalog includes databases tables, organize your datasets, and store their metadata for easy access and querying. Connections, manage and configure links to your data sources like S3, RDS, or Redshift. Crawlers automatically scan your data sources, detect schema and structure, and populate the data catalog. Glue Data Catalog, the central repository that stores all metadata, making it easy to search, query, and use data across AWS services. Here is a quick overview of the Data Catalog interface. In AWS Glue, a database is simply a logical container used to group related tables. Each Glue table represents your actual data, whether it's in S3, RDS, or Redshift, and stores important metadata like columns and file locations. The table schema defines the structure of that data, such as column names and data types. Together, these features allow Glue to manage metadata, organize data efficiently, and integrate seamlessly with the AWS Data Catalog for analytics and ETL. Next are connections. In AWS Glue, a connection stores all the details needed to securely connect to a data source or target, such as endpoints, credentials, and security settings. These connections can be used with services like S3, RDS, Redshift, and other JDBC sources, allowing Glue jobs to move and process data seamlessly. The key advantage is reusability. Once a connection is set up, it can be reused across multiple ETL jobs and crawlers, ensuring consistency and reducing duplicated setup. For example, a Glue job can use a connection to load data from S3 into Amazon Redshift. In the Connections interface, you define how Glue connects to external data sources. You select the connection type, such as S3, JDBC, RDS, or Redshift, then configure the endpoint, authentication, and network settings. Once saved, this connection becomes reusable and can be selected directly when creating glue jobs or crawlers, making data integration faster and consistent. Crawlers in AWS Glue automatically scan your data sources to understand their structure. They detect schemas, table definitions, and partitions, then store this information in the Glue data catalog. This gives you a single, unified view of all your data assets, including formats and partitioning details. By automatically discovering metadata, essentially labels that describe what the data contains, crawlers make data easier to query, manage, and process efficiently. Here is a quick overview of the crawler interface. Here we can access the classifiers. It is used to understand what type of data you're working with. They analyze data files to identify the format, structure, and data types, and then determine the schema automatically. This process, called schema inference, allows Glue to catalog data correctly without manual definition. Glue includes built-in classifiers for common formats like CSV, JSON, and Parquet, and also supports custom classifiers when you have unique data structures. Crawlers and classifiers work together but have different roles. Crawlers scan data sources and populate the Glue data catalog with tables and metadata. They can run on their own and automatically detect common data formats. Classifiers, on the other hand, are rules that help crawlers identify specific data formats or schemas, especially when you need custom handling. Think of classifiers as optional filters or shortcuts, useful when you want precise control or faster categorization without fully scanning everything. Next are workflows. These are used to orchestrate and schedule data pipelines. They allow you to connect ETL jobs and crawlers into a single flow and run them automatically in the correct order. Workflows can be scheduled or triggered manually, making it easy to automate and manage end-to-end data processing. Glue workflows use triggers to automatically start processing. This can be based on events like data arrival, a scheduled time, or an API call. They also support scheduling, allowing workflows to run at defined intervals or respond to events through Amazon EventBridge, enabling fully automated data pipelines. A single trigger in AWS Glue can control multiple ETL jobs or crawlers. It can be configured to fire based on different job states, such as succeeded, failed, timed out, stopped, or running, allowing you to control workflow execution based on job outcomes. Moving on to AWS Redshift. AWS's fully managed data warehousing service. It's designed to analyze large data sets using standard SQL, delivering high performance, scalability, and cost efficiency, making it ideal for analytics and business intelligence. Amazon Redshift is built for data warehousing and analytics. It uses columnar storage and massively parallel processing for fast queries, can scale from gigabytes to petabytes, and integrates seamlessly with other AWS services and BI tools. Redshift also offers advanced compression to save storage and speed up queries, automatic backups and snapshots for data protection, and strong security with encryption, IAM, and VPC support. It includes performance optimization tools and flexible pricing options, making it both efficient and cost-effective. Other key Redshift features include data distribution for efficient query processing, columnar storage for faster analytics, Redshift Spectrum to query data directly in S3, and concurrency scaling to handle multiple queries without slowing performance. It also provides backup and recovery to protect your data, efficient data loading for fast ingestion, robust security with encryption and access controls, and optimized query processing for high-performance analytics. In the Redshift Query Editor, you connect to your database by entering your credentials like cluster endpoint, database name, username, and password. Once connected, you can start running SQL queries directly from the editor without needing any external tools. Amazon Redshift offers two query editors. Query Editor 1 is the original web-based interface for running SQL queries, while Query Editor v2 is newer, faster, and provides enhanced features like saved queries, better formatting, and more seamless integration with multiple Redshift clusters. Moving on to AWS Athena. AWS Athena is a serverless service that lets you run SQL queries directly on data stored in structure to manage. It supports interactive queries, standard SQL, and works with partitioned data in formats like CSV, JSON, and Parquet. Athena uses pay-per-query pricing, making it cost-effective, and integrates with the AWS Glue Data Catalog and BI tools like QuickSight, Tableau, and Power BI for easy analysis and visualization. The Athena Query Editor is a web-based interface where you can write and run SQL queries directly on your S3 data. It lets you preview results instantly, save queries for later, and integrate seamlessly with the Glue Data Catalog to make querying structured and partitioned data easier, all without managing any servers. Moving on to AWS Secrets Manager. AWS Secrets Manager provides a secure, sensitive credentials like database passwords, API keys, and tokens. Make dates passwords, API keys, and tokens. It supports automatic rotation to reduce exposure risks, integrates seamlessly with services like RDS, Redshift, and Lambda, and offers granular access control and auditing to track who access secrets and when, helping maintain security and compliance. Here is a quick snapshot of the AWS Secrets Manager screen. Moving on to Parameter Store. Parameter Store provides a secure, centralized place to manage application configuration and secrets. It encrypts sensitive data, supports versioning and tagging to track changes, and allows different parameter types like string, string list, and secure string. This makes it easy to manage settings, passwords, and keys efficiently and securely. Lastly, we will discuss about the AWS Well-Architected Framework. The AWS efficient and cost-effective systems in the cloud. It is built around 5 pillars. Operational excellence focuses on monitoring, automation, and improving processes. Security protects data, systems, and assets through strong access control, encryption, and compliance. Reliability ensures workloads perform correctly and recover quickly from failures. Performance efficiency uses resources efficiently to meet system requirements and scale as needed. Cost optimization manages costs and maximizes value by avoiding unnecessary expenditure. These resources help you deepen your AWS knowledge. AWS Knowledge Atagda Framework provides best practices for building reliable, secure, efficient, and cost-effective cloud systems. AWS web papers offer detailed technical guidance on architecture, security, and AWS services. AWS skills and validate expertise to build skills and validate expertise. Thank you all for taking the time to join this AWS Fundamentals training. I hope you found it informative and helpful for your cloud journey.